deviation or sample standard deviation? So standard deviation is just a measure of how far a set of values is from its mean. The mean, remember, is the x with the bar over it. If we have a large standard deviation, that is an indication that we have a large distance between our values and the mean. If we have a small standard deviation, that means we have a small distance between the values and the mean. So we had some measures of central tendency a couple sets of notes ago. So we had we had measures of center is what I want to say. Measures of center. The measures of center all started with M. It was your mean, median, and mode. We now also have 3 measures of spread. Not jam. Oops. Okay, so the measures of spread are range, the IQR, and now standard deviation. Okay, the measures of center are telling us about the middle of our data. The measures of spread are telling us how far the data is spread out. Everybody okay with that? Okay. So we need to be able to decide whether we are going to pick a population or sample standard deviation. Now, these two have 2 different symbols. Population standard deviation, we use a sigma. It's a little Greek letter with the X subscript. It kind of looks like an O with a little toupee. Yeah. Or some people think it looks like if you kind of like reflected a P and then rotated it, you'd get a sigma. Okay, the sample one is easier to remember. The sample one is an S with a sub X. So you can see the S is for sample. The little sigma with a toupee is for population, and then the S is for sample.
The population is going to rotate the Q.
What?
It's going to rotate the Q.
Yeah, but if you think about it, aren't a P and a Q just reflections of each other?
Yeah.
Yeah, so that, yes, we're saying the same thing. Okay, so in order to use this population standard deviation, you have to have data on everybody in the entire population. So if I wanted to survey all of the kids in this room and ask them how many dogs, Chad has asked all 5 principals at Capital City High School how many pets they have, and he recorded their responses in the table. Now he wants to find the variability in his data. So we're going to find the standard deviation, and which standard deviation should we use?
Standard. Or the center.
Did he ask only some of the principals?
Oh, the population.
Yeah, he asked the entire population of principals in this building. So we are actually going to use the population. Okay, so that is the one with the little crazy sigma with the sub x. Okay, so our first step is that we have to find the mean. So that's pretty easy. We just add them all up and divide by how many there are. So that would be 6 plus 3 plus 3 plus 2 plus 1 divided by 5 principals. Okay, so that's 15 over 5, which reduces to 3. And that is our mean, the x with the bar. Now, the standard deviation, remember, is a way that we can find, on average, the distance from the mean. So we are going to calculate how far each of our data points is from this average. Okay? So how far is 6 from 3? Well, to find that out, we just do 6 minus 3, and we get 3. It's 3 units away. Okay, how far is 3 from 3? 3 minus 3 is 0, right? 3 minus 3 again, still 0. 2 minus 3, well, it's negative 1, right? And then 1 minus 3, that's negative 2. Now we're going to use those distances. We're going to add them, and we're going to square them, add them all up, and then divide by how many there were, and then we're going to take the square root of that whole thing. And it's going to look bonkers crazy, but we're going to explain it once we're looking at it. So just humor me for a bit while it looks gross, and then we'll talk about it, okay? All right, here we go. So it's for sigma sub x. It's a big square root. Make it nice and tall because we're going to have a numerator and a denominator. Oops, I forgot the equal sign. Okay. Okay, give yourself a numerator and a denominator with a great big fraction bar. So my first distance was 3. When I square a 3, do I need to put parentheses around it? No. So I can do 3 squared plus a 0 squared plus another 0 squared plus, now here's where it gets tricky, because I want to square a negative 1. So I need to put parentheses around it so that I square it and it turns positive. Is that okay with everybody? Okay. So I'll have a negative 1 squared plus also a negative 2 squared. Okay, in the denominator, we have to divide by how many principals we asked. And we asked all 5 of them, so we put 5. Okay, so let's think about this for a minute. If we wanted to find the average distance, couldn't we just add up the distances and divide by how many there were? You'd think so, right? But what happens if we add a positive 3 and a negative 1 and a negative 2 and some zeros? Yeah, we cancel each other out because of the positives and the negatives. So some bigwig mathematicians were like, okay, what we're going to do so that we don't cancel each other out is that we're going to square everybody to get rid of the negative signs. Then we're going to divide by 5, and then we're going to take the square root of the whole thing. Does that make sense? So that's why all the squaring and square rooting is happening. Cool? All right, perfect. So let's put this in the calculator. When you put it in the calculator, you're going to want to make sure that you are dividing the entire numerator by the 5. So we're going to have to put parentheses around this whole numerator. Otherwise, we'll only divide the last term by 5. So this is how it looks. Okay, find the square root. Great big parentheses. 3 squared plus 0 squared plus 0 squared plus, I need to square my negative 1. Make sure he goes in parentheses. And then I have also a negative 2 to square. Make sure he goes in parentheses. Now I'm going to close my big parentheses, my outside set of parentheses. And now I can divide by 5. Do you see how my 5 is still under the radical? That's what I want, because when we drew that great big radical sign, it covered the numerator and the denominator. Okay, cool, cool? Cool, cool, cool. Okay, good. Okay, then hit enter. I got 1.673. It says to round to the nearest thousand. Okay, now we're going to check it on the calculator the easy way. You guys are going to like this. Okay, we're going to go to stat. Oh, first let's clear the memory. How do we clear the memory? Good. Second plus 712. How do we turn our yes, we turn the correlation coefficient back on with the mode, and we go all the way down to stat diagnostics, and we turn them on because we need the wizards and the diagnostics on. Okay, then go to stat. Go to edit, and we're going to put in our list of answers from the principles. So the first one said 6, then a 3 and a 3 and a 2 and a 1. Okay, back to stat. Now we're going to calculate our one variable statistics. Okay, we know and love the screen. All of our favorite information is here. So you can scroll through yours and see what you can see, but I have mine printed out right here. And you can see that my population standard deviation right here matches. It's 1.673. Pew. Okay, so let's label these real quick. The very top one is the mean. Okay, this S sub x is the sample standard deviation. The sigma sub x is for the population. N is the number of principals we surveyed. Okay, and then down at the bottom, we have our min, our max, our first and third quartiles, and our center. So down here, we have an entire box plot. We could just make a box plot off of that information right there. Okay, questions for me? Okie dokie. Let's flip. Okay, guys, what we're going to do for this one is we're going to set it up with the big radical, and then we're going to do it on the calculator the easy way, okay? So now Chad is curious about the variability for the number of pets owned by the student body. He doesn't have the time to ask everybody, so he's going to pick a random sample of 5 students to ask. He records their responses in another table. So this time, which should we use? Sample. So that is the S sub x. Okay, oops. I changed, this problem used to be about bananas, and I've left some banana stuff in here. Sorry, guys. Okay, now we are going to set up the crazy radical so you know what it looks like, and then we'll do it on the calculator. So this time we're finding S sub x. Okay, we need a great big radical. Ew. Okay, that's not much better. It's fine. Um, what was the first step on the other side? What did we have to find? The mean, because we're trying to figure out how far everything is from the mean, right? So we need the mean. So we're doing 2 plus 3 plus 7 plus 1 plus 2 and dividing it by 5. So that, I think, is 15 divided by 5 again. So we get 3 for the mean again. Okay, so how far is 2 from the mean? So 2 minus 3 is -1, and we square it. Plus 3 minus 3 is 0, and we square it. Plus 7 minus 3 is 4, and square it. What? Um, it doesn't matter if you put the positive ones and 0 in parentheses or not. The ones that absolutely have to be in parentheses are the negative ones, right? Because when we square a negative, we should get a positive. But if you don't put the parentheses, you won't get that positive. Did I answer your question? Yeah. Okay. And then 1 minus 3, that is a -2, and square it. And 2 minus 3 is a -1, and square it. Okay. Now, so far the formula is exactly the same. Here's the difference. Because this time we're only testing a sample, we have to allow for the fact that there might be more variability out there than we even know about. Okay? Maybe a couple of people have like 20 pets. Like, we don't know. They weren't in our sample. Okay? So we have to allow for the fact that there's some unknown out there. So we're going to divide by not 5, but a slightly smaller number, which is 5 minus 1. Yep, 4. So it's like the number of elements in your set minus 1. Take away 1. Okay, let's put it in the calculator. Go back to stat, edit. Was it 1? Help me out, I don't remember. Oh, okay, no, it's the number of pets. It's 2, 3, 7, 1, 2. Sorry, I messed up. 2, 3, 7, 1, 2. So we just start with our original data. We go to stat, we go to calculate, and we go to our one variable stats. And make sure you get the, whoops. Oh. What did I do? Ew. Are you making fun of me? Oh my gosh. Okay, I'm just going to go back and try it again. I don't know what I hit. Okay, so you can see all of the stuff here. Which standard deviation do we want? Yeah. Okay. So we did it in pink. S sub x was it 2 point?
It was 2.355.
Okay, 2.345. Thank you. Okay, so now we are going to compare the variability between this sample and the population on the front. And that was, oh, you gotta be kidding me. 1.673. Okay, so which standard deviation is larger? The sample. So what does that mean? What did we say that a larger standard deviation meant? Yeah, we have a greater distance between the values and the mean, so our data is more spread out. Okay. So data is farther from X bar or more spread out. Questions? Yep. You got 4 minutes. Oh, yeah.
All right.
Okay. Yes. Okay. So here we have tables listing the average ages of Academy Award winners for Best Actor and Best Actress in randomly selected decades from the 1920s through the 2010s. Anybody notice anything fun just by looking at them?
No.
Okay, they have decimals. So is this going to be something we want to do by hand? Correct. Okay. No way. All right. Look at part A. Should we use population or sample?
Sample.
You are correct. How did you know?
Because isn't it because like it's like this like the population of like that classroom or whatever it is. I mean, just the best actors.
Okay, what was the key word in here that told you?
Average ages of primary awards winners.
Does it say for all the decades?
No. So like this. So like
Randomly selected. Okay, that's what tells you that it's a sample. Okay, so we're going to use sample. Okay. We are going to find the mean, median, range, and standard deviation and fill out this table. So let's start with the guys. Ladies always get to go first. We'll start with the guys. Go to stat, edit. Go ahead and clear your list. Clear enter on the name of the list. I'm putting in 49, 42.8, 41, 45.5, 44.8, 47.4, and 43.3. Okay, everybody should be practicing this because on your test days, I'm going to have amnesia and I'm not going to remember how to do it, even if I wanted to tell you, which I don't because it's your test and you should know. All right, let's go back to stat. Then to calculate, we'll calculate our one variable stats. And look at all our goodies. We got pretty much everything we need. All right, let's fill in this table. What did you guys get for the mean? Yes, 44.829. The more often you use this little X bar symbol for mean, the better it'll stick in your brain. What about the median? Oops. 44.8. Okay, the range. What's the biggest age for guys? 49. And the min? Okay, 49 minus 41 is 8. All right, what's the standard deviation? We said use sample. Correct, 2.756. Okay, best actresses. Okay, stat, edit, clear your list. Go up to the list name, clear, enter. Okay, I got 29, 31.5, 36.7, 36.1, 35.7. Hey guys.
Yes, sir.
Okay. 45.4 and 36.1. Okay, back to stat. Calculate our one variable stats. Okay. Here we have our sample standard deviation. Okay, we've got our mean, we've got our median, and we can quick calculate the range by doing the max minus the min. Okay, for the mean, I got 35 point, what, 78, I got 786. Am I crazy? Yeah, 786. Okay. Median. I got 36.1. For the range, it was 45.4 minus 29, and you should get 16.4. Okay, so 5 point. Ooh, let's talk about rounding this one. Okay, we're looking at our sample. So we're at 129 and then a 7. So we got to go to 130. Does everybody see that? Okay. Hey, would you shut our door, please? Thank you. Okay, that's our tables. Okay, part C says that we have to compare the mean and the median. Okay, these are our measures of center. what can we conclude about our data looking at these measures of center?
The best actors are lower.
Lower, what does that mean in this scenario?
Younger.
Younger. So according to our mean and median, the average ages of the actresses are lower than their counterparts for actors, right? Okay, good. All right, so comparing or based on mean and median, the actresses are younger on average. That doesn't mean that every single one of them is younger than all of the guys, right? It's just on average, they're younger. Period. Okay, let's look at the next one, which says, now we have to compare the range and standard deviation for the actors and actresses, and then make a conclusion. So these are our measures of spread. All right, let's fill in the bubble while you think. Remember that standard deviation is a measure of how far the data is from the mean. Who has the higher standard deviation? The actresses. Who has the higher range? The actresses. Okay, so we know that they're not older because we just said that they were younger. So if the standard deviation and the range both bigger for the actresses, what does that mean about our data? They're not older. We already know that. Let's go. They're better? I don't know about that. What does a large standard deviation mean? Large distance from the mean. So what do we know about the ages for the actresses? They are farther from the mean. Okay? And the range is telling us the same story. The ages are more spread out. Okay? There's a bigger spread. The dudes are older, but the ladies are more spread out. Does that make sense to everybody? Okay. So, based on range and standard deviation, comma, the actresses ages are more spread out and farther from the mean, X bar. Okay, so If the ladies are more spread out and farther from the mean, that means that the actors are closer together and closer to the mean, right? Okay. Any questions about this? Okay.